Welcome to the dawn of a new industrial cycle, where thousands of tons of discarded steel await a miraculous transformation in this ultra-modern recycling sanctuary. The rhythmic clanging of heavy metal echoes through the yard as hydraulic excavators begin the first step of sorting through mountains of forgotten iron and steel. Moving from chaos to order, the raw material enters a sophisticated 5.0 automated system where cutting-edge sensors prepare to analyze every single fragment. Industrial magnets pulse with invisible energy, precisely plucking specific alloys from the belt as the system begins the meticulous process of high-speed material categorization. Sophisticated laser arrays scan the chemical signature of each piece, instantly identifying carbon content and alloy levels to ensure only the highest quality raw materials. In the central hub, advanced algorithms map out the journey of every ton, optimizing the flow of material to maximize efficiency and reduce waste significantly. High-speed robotic arms work with superhuman precision, removing non-metallic impurities and low-grade fragments with a speed that the human eye can barely track or follow. Massive scrap buckets now glide along automated rails, carrying their curated loads toward the heart of the facility, where the true heat and transformation will begin. Every mechanical lock and safety system engages with a heavy metallic click, ensuring that dozens of tons of steel are secured for their high-temperature journey. Looking up, the sheer scale of the engineering becomes apparent as these metal giants move silently through the air, guided by invisible digital pathways and sensors. Even the smallest fragments are not ignored, as vibratory feeders and air jets separate the dust and fine particles to ensure a pure melting process later. Quality control remains a priority at every step, with specialized technicians performing random spot checks to verify the accuracy of the automated scanning systems. The density of the load is carefully calculated by AI, ensuring that each furnace charge has the perfect mix of materials for the specific steel grade. Massive overhead cranes with enormous lifting capacities take over, their steel cables straining under the weight of the raw material destined for the fiery furnace. As we leave the sorting yard, the temperature begins to rise, and the atmosphere shifts into a realm of extreme energy and raw industrial power. The entire process is mirrored in a digital twin, allowing operators to monitor every gram of material as it moves closer to the electric arc furnace. Hydraulic power on a massive scale prepares to release the scrap, as a carefully choreographed dance of steel and fluid power that defines modern heavy industry. The melting shop is a cathedral of fire and iron, a space where the air is thick with the promise of transformation and the smell of ozone. Safety signals pulse in the dim light, warning that a massive charging operation is about to begin as the gates to the furnace area slide open. Every movement is deliberate and tracked, ensuring that the heavy steel reaches its destination without a second of downtime or a drop in productivity. Positioned and ready, the scrap bucket hangs over the furnace, the rising heat from the previous melt already beginning to shimmer and distort the air. The supply chain is endless, a constant river of iron moving from the past into the future, fueled by the circular economy of sustainable steel production. Within this pile of scrap lies the skeleton of old bridges, cars, and buildings, all waiting to be stripped of their past and forged into something new. Maintenance is handled by specialized robots, keeping the eyes of the factory clean and accurate in an environment that is otherwise harsh and unforgiving. As we conclude the sorting phase, the waste of yesterday has been transformed into a precious feedstock, ready for the intense fire of the arc furnace. The heart of the plant prepares to beat as the massive roof of the electric arc furnace lifts, releasing a surge of intense heat and steam. In one thunderous motion, dozens of tons of steel scrap are plunged into the furnace, a dramatic beginning to the most intense phase of the recycling process. The chamber is sealed, creating a controlled environment where extreme energy will soon be unleashed to break the molecular bonds of the solid iron. 3 massive graphite electrodes, the conduits of raw power, descend into the darkness to initiate the most spectacular display of industrial energy on the planet. The strike occurs with the force of a lightning bolt, a sustained electric arc that begins to tear through the metal, generating temperatures exceeding 1600 degrees. The roar of the furnace is a physical force, a deep acoustic vibration that speaks to the incredible amount of electricity being consumed in this very moment. Through the thermal glass, we witness the solid scrap yielding to the heat, turning into a glowing orange mass as the melting process begins in earnest. Every few seconds, the hall is bathed in a strobe-like blue light, a visual reminder of the sheer scale of the power being harnessed here today. The electrodes themselves are marvels of engineering, designed to withstand the brutal environment and conduct the massive currents required to liquefy solid steel. Complex water cooling systems wrap around the furnace shell, working tirelessly to prevent the intense internal heat from compromising the structure of the massive vessel. At the base of the furnace, a pool of liquid iron begins to collect, a churning sea of molten metal that was once discarded industrial waste. Oxygen is injected with precision, accelerating the melting process and helping to oxidize impurities that will eventually form a layer of slag on top. The impurities, or slag, are carefully removed, floating on the surface like molten glass, leaving behind a purified pool of liquid steel deep within. Additional scrap is added to maintain the volume, creating another spectacular display of sparks and flames that illuminates the dark corners of the smelting hall. The entire furnace, weighing hundreds of tons, tilts on its rockers with surprising grace to discard the unwanted slag into a specialized collection pit below. The target temperature has been reached, is 1620 degrees Celsius, a heat so intense it mirrors the conditions found deep within the Earth. An automated probe dives into the liquid sun, capturing vital data and a physical sample that will be analyzed in seconds by the laboratory. The sample travels at high speed through pneumatic tubes, arriving at the lab where advanced spectrometers will verify the exact elemental makeup of the melt. With the chemical profile confirmed, the steel is now ready for the next stage of its journey, perfectly balanced for its intended industrial application. A massive transport ladle moves into position, preheated to prevent thermal shock as it prepares to receive the full weight of the molten steel. The tapping begins, and a blinding stream of liquid steel cascades into the ladle, a waterfall of light that signifies the successful completion of the melting. The ladle fills with dozens of tons of liquid fire, the radiant heat so powerful it can be felt from hundreds of feet away across the shop. Precision chemical adjustments continue even during the pour, as fluxes are added to further refine the steel and prepare it for the refining furnace. Sophisticated tapping technology ensures that no slag enters the ladle, keeping the steel as clean and pure as possible for the high-end applications ahead. Once full, the ladle is hoisted into the air, a glowing vessel of potential moving through the industrial landscape toward the secondary refining station. The journey from the arc furnace to the refining stage is brief but critical, as the temperature must be carefully maintained for the next process. Specialized personnel in advanced protective gear oversee the movement, ensuring that every safety protocol is followed during this high-risk transport phase. The ladle's design is a marvel of ceramic and steel engineering, capable of holding back the tremendous pressure of the liquid metal until the exact moment. At the ladle furnace, the steel will undergo final chemical tuning, adjusting its properties to meet the exact requirements of the customer's specific order. Argon gas is bubbled through the melt, stirring the liquid steel to ensure a perfectly uniform temperature and chemical distribution throughout the entire ladle. Specific ferroalloys are added by automated systems, precisely tuning the hardness, ductility, and corrosion resistance of the steel for its future life in the world. The ladle furnace electrodes hum with a different frequency, providing just enough energy to keep the steel at its optimal liquid state for casting. The surface of the steel is a mesmerizing landscape of fluid dynamics, reflecting the immense energy and precision that goes into modern metallurgical science. One last chemical check ensures that everything is perfect, a final gatekeeping step that guarantees the quality of every single ton of steel produced here. The ladle now moves toward the towering continuous caster, where the transition from liquid light to solid strength will finally take its physical shape. Placed into a massive rotating turret, the ladle is now part of a continuous flow, ensuring that the casting process never stops for a moment. The sequence is seamless, with a second ladle always standing by to take over, maintaining a constant stream of liquid steel into the casting molds. Skilled operators monitor every second of the pour, balancing the art of steel making with the raw precision of the most advanced automated machinery. The pour begins as steel flows from the ladle into a tundish, which acts as a reservoir to distribute the metal into the casting molds below. Acting as a vital buffer, the tundish ensures a steady and controlled flow, allowing the steel to be split into multiple strands for efficient slab production. In the water-cooled copper mold, the magic happens. The outer shell of the steel solidifies in an instant, even as the core remains liquid and glowing. The steel slab emerges from the mold, a continuous length of hot metal that begins its long journey through the cooling and shaping rollers. High-pressure water sprays blast the surface, accelerate the cooling process, and creating a dramatic atmosphere of mist and steam within the casting chamber. The slab slowly curves from its vertical descent into a horizontal path, guided by hundreds of precision rollers that support its immense and growing weight. As it travels, the steel transitions from a bright yellow heat to a deep, resonant red, signaling the structural transformation occurring within its crystalline lattice. The scale of production is massive, with multiple strands of steel moving in unison, creating a rhythmic and powerful visual of modern industrial output. A precision torch cutting system prepares to act, moving in perfect synchronization with the moving slab to slice it into the exact length required. The torches roar to life, cutting through the thick steel like a hot knife through butter, throwing a fountain of golden sparks into the pit below. The individual slab is now born, a solid block of high-grade steel that carries within it the chemical blueprint established back in the arc furnace. Every slab is instantly identified with a permanent heat number, ensuring total traceability from this moment through every future stage of its industrial life. The slabs are stacked in the cooling yard, where they release their immense thermal energy, creating a landscape of heat that can be felt from afar. Up close, the surface of the cast slab shows a rugged, industrial beauty, a raw texture that will soon be smoothed out by the rolling process. Giant tongs descend from above, gripping the heavy slabs with hundreds of tons of pressure and moving them with the ease of a child's toy. The journey continues as the slab is directed toward the reheating furnace, where it will be brought back to the perfect temperature for rolling. Inside the furnace, a wall of flame and blue heat awaits, designed to soak the steel until it is soft enough to be shaped by the mills. Emerging from the furnace, the slab is a radiant orange, its internal temperature perfectly uniform and ready for the immense pressure of the rolling stands. Ultra-high pressure water jets blast the surface, stripping away the dark scale to reveal the clean, hot steel that lies beneath for a perfect finish. The roughing mill stands ready, a mountain of iron and steel designed to exert thousands of tons of force to begin the reduction process. As the slab enters the rolls, a thunderous boom echoes through the plant, a sound that represents the raw power of mechanical deformation in action. With each pass, the slab grows longer and thinner, the massive rolls squeezing the steel and refining its internal grain structure for maximum strength and durability. The steel is now a long plate, speeding across the transfer tables toward the finishing tray, where it will be transformed into its final thin strip. A massive crop shear slices the leading edge, ensuring the strip has a clean and perfectly shaped head to enter the high-speed finishing stands. The finishing train is a marvel of coordination, with 6 or 7 stands working in perfect sync to reduce the steel to its final, precise thickness. The speed increases dramatically, and the steel strip becomes a blur of red light, racing through the mill at over 20 meters per second. Invisible X-rays monitor the thickness to within microns, providing constant feedback to the mill's computers to adjust the roll pressure in milliseconds. Leaving the last stand, the strip passes under curtains of laminar cooling water, which carefully manage the temperature to lock in the desired mechanical properties. The run-out table is a long highway of rollers, where the steel begins to lose its bright glow and turns into a dark, powerful strip of metal. At the end of the line, the coiler catches the speeding tip and begins the high-speed wrap, forming the massive, hot-rolled coil that we see today. Centrifugal forces and precision mechanical arms work together to ensure the coil is wound tightly and evenly, a testament to modern high-speed machinery. A completed coil is ejected, and a 30-ton masterpiece of engineering that is still hot enough to radiate heat across the entire finishing bay area. The coils move in a stately parade on heavy-duty conveyors, each one destined for a different part of the world to become something essential. Automated strapping machines apply high-tension steel bands, securing the coil against the internal stresses that want to pull it apart as it cools. Artificial intelligence eyes inspect every inch of the surface, looking for even the smallest imperfection that could affect the quality of the final finished product. Driverless vehicles navigate the warehouse with perfect precision, moving the heavy coils to their storage locations without the need for human intervention or steering. The warehouse is a vast library of steel, where each coil's location is recorded in a database, ready for shipping at a moment's notice to anywhere. Logistics are managed through integrated digital platforms, ensuring that the right coil reaches the right customer at the exact time it is needed for production. A quick scan of a QR code reveals the entire history of the steel, from the day it was scrapped to the moment it became a coil. This is a new kind of factory, designed for sustainability, with renewable energy sources and advanced filtration systems that protect the environment for future generations. Every drop of water is treated and reused, a closed-loop system that reflects our deep commitment to preserving natural resources while producing world-class industrial materials. The journey goes global as the coils are loaded onto massive ships, ready to cross oceans and contribute to the infrastructure of the modern world. From the depths of the scrap pile to the belly of a cargo ship, the cycle of steel is a testament to human ingenuity and engineering. By choosing to recycle, we save 75% of the energy and significantly reduce carbon emissions, making this process the backbone of a greener future. As the day ends, the fires of the furnace continue to burn, a symbol of the eternal and sustainable cycle of the world's most recycled material. The steel we make today will become the cars of tomorrow, the bridges of our cities, and the silent strength that holds our modern civilization together. Thank you for joining us on this journey through the fiery life cycle of steel, where innovation and sustainability meet to forge a brighter tomorrow for everyone. The human element remains central as expert eyes and years of experience guide the technology to achieve the perfect balance of heat and chemistry. Massive mechanical gears, lubricated by advanced systems, transmit the power of thousands of horses to the rolls that shape our world's heavy infrastructure. High-voltage electricity is the lifeblood of this process, delivered through specialized transformers that can power an entire city at the flick of a switch. The rollers are designed to handle extreme thermal stress, maintaining their precision and shape despite being in constant contact with red-hot metal all day long. Quality assurance is relentless. Every batch is tested to its breaking point to ensure it meets the rigorous safety standards of international building codes and regulations. Efficiency is key, and every gram of molten metal is accounted for as the furnace completes its cycle, ready to be refilled for the next charge. The electrode regulation system adjusts in microseconds, maintaining the perfect arc length to optimize power consumption and prevent any damage to the internal furnace lining. From this silent, air-conditioned room, the power of 10,000 tons is controlled with simple movements of a mouse and clicks on a digital screen. As the precision of the oxy-fuel torches is incredible, leaving a clean, straight edge on the thick steel slabs that requires no further machining or trimming. Any minor surface defects are ground away by automated machines, ensuring that the finished hot-rolled coil will have a flawless and perfectly smooth surface finish. The strength of hydraulics is harnessed to exert millions of pounds of force, squeezing the steel into the exact thickness required for the customer's application. At night, the factory becomes a spectacular world of shadows and fire, where the glow of the steel creates a cinematic landscape of industrial power. Sensors are the nervous system of the plant, communicating with the central brain to coordinate the movement of thousands of tons of metal simultaneously. Sustainability is built into every pipe and tank as the facility manages its thermal footprint with advanced cooling towers and heat recovery technology for efficiency. The future of logistics is here, out with autonomous machines handling the heavy lifting and ensuring that the warehouse remains organized and safe for human workers. Flexibility is a hallmark of modern steelmaking, allowing the plant to switch between different high-performance alloys with just a few keystrokes in the control system. These high-tech ceramics are the only thing standing between the liquid fire of the steel and the structural metal of the ladle, protecting it from melting. The slag is not wasted. It is processed into high-quality aggregate for road construction, ensuring that every byproduct of our process has a useful second life. Giant baghouses and filtration systems capture every particle of dust, ensuring that the air leaving the factory is cleaner than the air entering it. The final product is a thing of beauty, a mirror-like surface that hides the incredible strength and resilience forged during its intense journey through the mill. Science and industry walk hand in hand here, with the latest metallurgical research being applied in real time to create the next generation of advanced steels. The people who work here are the true heart of the operation, bringing their passion and expertise to a job that builds the foundation of our world. From high above, the crane operator orchestrates the movement of metal, a vital link in the complex chain that transforms scrap into high-value industrial components. Precision maintenance keeps the machines humming, with automated lubrication systems ensuring that every moving part operates with minimal friction and maximum long-term reliability. The cooling process is carefully controlled to manage the internal stress of the steel, preventing any warping or cracking as the metal reaches its final state. These massive copper conductors are the veins of the system, delivering the incredible energy required to melt thousands of tons of metal every single day. E-rail transport offers a highly efficient way to move our massive production to domestic customers, further reducing the environmental impact of our total logistics chain. The coiling process is the final act of the mill, a high-speed rotation that packs the power of the steel into a compact and transportable form. The completed coil is handled with care as hydraulic systems gently transfer the hot metal to the conveyor that will carry it to the storage bay. Sound waves probe the heart of the steel, looking for any internal flaws or air pockets that could compromise the integrity of the finished product later on. The atmosphere in the cooling section is ethereal, filled with a mist that hides the incredible science being used to toughen the steel at its core. Innovation never stops, and our research center is constantly experimenting with new formulas to make steel lighter, stronger, and even more sustainable for future use. Digital modeling allows us to predict how the machines will behave under extreme load, ensuring that we can push the limits of production without sacrificing safety. By integrating renewable energy directly into our Offa Musau operations, we are leading the way toward a carbon-neutral steel industry that respects the planet and its people. Even our internal infrastructure is a testament to recycling, with roads and paths constructed from the very slag we produce in the refining process every day. The continuity of the process is its greatest strength, a never-ending cycle that keeps the production line moving and the world's supply of steel constant. Precision sensors provide a constant stream of data, allowing us to maintain the exact temperature required for the perfect solidification of every single cast slab produced. The beauty of the finished coil lies in its precision, a tightly wound, uniform roll of steel that is ready to be transformed into any shape needed. This industrial landscape never sleeps. A 24/7 operation that hums with the energy of creation and the tireless pursuit of metallurgical excellence and modern innovation. Global trade starts here, with every shipment meticulously documented and tracked as it makes its way to the ports and then to international markets across the globe. The steel begins its final journey, carried by massive vessels that are themselves made of the very material they are transporting to distant shores and markets. The cycle is complete when the steel reaches its final destination, providing the strength and skeleton for the buildings that will shape our future skylines for decades. From rolls of steel to the curves of a modern car, our products are the silent partners in the movement and safety of people all over the world. The resilience of our steel is tested every day in the bridges that connect our communities, standing firm against the elements and the passage of time itself. As each new day begins, or we rededicate ourselves to the goal of making the world's most recycled material the foundation of a cleaner and greener global economy. The cycle begins again, a testament to the endless potential of recycling and the human will to build a better future with the materials of yesterday. Safety and sustainability are our guiding principles, ensuring that every ton of steel we produce is made with the utmost respect for human life and our environment. Our commitment to the environment is verified every day, with rigorous testing of our emissions and water use to ensure we are the cleanest plant possible. The steel coil is the ultimate symbol of the circular economy, a compact and powerful representation of a process that turns waste into high-value wealth for all. Looking from above, the factory is a model of industrial harmony, a place where technology and nature coexist to provide the materials that the modern world needs. The pride of our workers is our greatest asset, reflecting the shared goal of producing the highest quality steel while leading the way in sustainable industrial practices. Toward the horizon, our steel carries the promise of progress, moving to every corner of the earth to build a future that is as strong as it is sustainable. 100% recyclable steel is the material of the future, and we are proud to be at the center of its incredible and fiery life cycle today. A final look at the finished product reminds us that through fire and pressure, we have created something of lasting value from the relics of the past world. Steel for the future, green for the planet. Join us again as we continue to forge the world of tomorrow through the incredible power of industrial recycling.